With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, welcome to Doubtnut. So we have a question here. The question says, which of the element is not a typical transition element? So we have been given 4 elements here, that is Fe, iron, Pd, that is palladium, Cr, that is chromium, and Zn, that is zinc, and we have to identify that which is not a typical transition element. So for this, first of all, let us understand that what is a transition element. So we have been asked transition element. So we will understand the meaning of it first. So transition elements, the elements or the atoms of D block in a periodic table are known as transition elements. Why these are known as transition elements? Because they have partially filled d orbital. Now this partially filled d orbital, this state can be found in two possibilities. The two possibilities are whether in free state they have a partially filled d orbital, that is uncombined, or when oxidized, that is in their commonly found oxidation states, they have a d orbital. So if an element is fulfilling this criteria, it is known as a transition element, because when the d orbitals are unfilled, there are transitions of electrons, thus they are known as transition elements. Now let us see that these elements which have been given to us, we will see the electronic configuration to identify the nature of these elements and then decide that which one is not behaving typically. So we will see the electronic configuration. So we have been given 4 compounds, that is iron, Fe, which is number 26. We have been given palladium, which is number 46. The third one we have is chromium, that is Cr. This one is number 24. And the last one we have is zinc, which is number 30. So if we see the electronic configuration of all these elements here, for ferrous, that is iron, we have, it is argon, that is Ar, 3d6, 4s2. For palladium, that is krypton, that is Kr, 4d10. For chromium, that is again argon, 3d5, 4s1. And for zinc finally, again we have argon, 3d10, 4s2. Now let us analyze the electronic configuration of all these elements. So what happens here? Let us see here. If we see ferrous, that is iron, we talked about a condition that either in the free state or in common oxidation state, there should be partially filled d orbitals. So we see in free state, there are partially filled d orbitals. So this will behave as a typical transition element. Now if we talk about palladium here, palladium is having 4d10. So in the free state, there are no free d orbitals, no partially filled d orbital. But if we talk about the second condition, that is having common oxidation state, so +2 is a common oxidation state of palladium, common OS, that is we have +2 here. So in the +2 oxidation state, if we see the configuration of palladium, it becomes something like this, that is Kr, 4d, 8, 5s, 0. So here we see there are free or partially filled d orbitals. So this will also act as a typical transition metal, typical transition element. So this again we have a typical transition element. If we talk about chromium, we can clearly see here that there are partially filled d orbitals. So this similarly will also act as typical transition element. Now again, if we talk about zinc here, we can see that in the free state, we talked about the condition, no partially filled d orbitals, no d orbital, partially filled. But if we talk about the common oxidation state, that is, we have +2 for zinc, the electronic configuration becomes, EC becomes 3d10 4s0, because the electrons are first pulled from the s orbital. So that becomes s0 and the d orbitals remains fulfilled intact. Fulfilled d orbital. Fulfilled d orbital. Now since the d orbital is fully filled, zinc cannot accept any electron in its d orbital, hence there are no transitions. So this, though included in the d block, does not behave as a typical transition element. Zinc does not show typical transition behavior. So it is not a typical transition element, hence not a typical transition element. So I have explained you the reason here, because the condition to behave as a transition element was that it should have a partially filled d orbital for the transitions, because if you see the orbital of zinc, it is something like this. Even in the common oxidation state, that is +2, so d has 5 orbitals, so it is something like this. All the orbitals have paired electrons, so you can see that there is no space for accepting the electrons here. Electron will not be accepted here, hence there are no transitions, and this is the reason that zinc does not form any colored aqueous ions. Zinc doesn't form any colored aqueous ions, because colored ions are formed when there is transition of electrons in the d block, in the d orbitals, because there are no vacant d orbitals, so hence we do not see any compounds of zinc that give colored ions in aqueous form. So this is the whole explanation, and if we see your question here again, the answer is zinc here, which you can write down, by the way. Answer is zinc, but you should also know the explanation that why is your answer zinc. So I have given you the whole explanation. I hope you have understood the whole concept, and you can see the video again and note down the important points. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.